So it's now being recorded. Now let me come back. This special function,
Okay, sir.
right? Special function, we use them to solve complex differential equation. And this complex differential equation, they always arise in physics and in engineering, because you are doing I usually tell my students that whenever they are in physics class, then I consider them to be physicists. So whether you're doing conversion or I take you equally like a physics student. So that's why I don't discriminate. And the reason is maybe tomorrow you become a lecturer, you will be able to. There are some complicated questions that you only need this special function to solve them, right? So for example, what we're going to do today, we're going to see what is referred to as gamma function. We'll see beta function. Then we will not look at Bessel function and Legendre polynomials for today. But I'm going to take you a little bit through hypergeometric function. I mean, hypergeometric function. Then maybe if we have time, we will now look at Bessel and Legendre polynomial. Then the class will be over. Now so we'll have one more class after this, because I want you to have idea of what is Bessel function and Legendre polynomial. Okay, what is it? What do we use it, and how do we use it?
Yes, sir.
What is it for? So this function actually, all the time we see such function in quantum mechanics. When you want to study, you want to go into details in terms of quantum mechanics. Then when we want to talk about fluid dynamics or electromagnetism, all this concept of special function comes into play. Or when you want to look at general relativity, okay? Now, what is gamma function? You can see, I'll
Yes, sir.
go gradually. Have you seen this symbol before? Have you seen this type of symbol? I told you, no distraction. Somebody is distracting you already. Are you there?
Yes, sir. Yes, sir.
I said, don't have distraction. This class is not a simple class.
I've sent him to the city room, sir.
You should lock yourself now. In the next 2 hours, I will just be very quick, and then you'll be able to pick it from there, since you're a very sharp student. Okay?
Yes, sir.
Okay. The question I ask is, this is gamma function. Have you ever seen this type of symbol before?
Yes, sir.
Where?
That was on my undergraduate.
Jesus. You're a postgraduate student.
No, sir. I've a degree before, but I want to do a conversion.
Okay, I thought you were a postgraduate student, because I thought this the other lady. I used to teach one lady like that. I don't know. Okay,
No,
let's go back. So
no,
this
sir.
is a gamma function, right? I know you used to use your past notes to read, right?
Yes, sir.
Okay, so now if you have seen, this is very gamma function. Now this gamma function, if you look, this gamma function is written in terms of n. Why? So this is a definition of a
Yes,
gamma
sir.
function. Anytime we talk about gamma function, what the key point to note here is gamma function must always start from 0 to infinity. In case it starts from minus infinity to negative infinity, you must change it. You must take from negative to 0, then 0 to infinity before you'll be able to use gamma. So this is the definition of gamma. Gamma again starts from 0 to infinity. And then anything that has to do with gamma, whatever you see here, it is what appears here, right? Any other thing remain. Some books, we can have, instead of using X, we use T. Then this place we use T, right?
Yes, sir.
Then again, these are just definition. Again, it is realized that whenever we have this type of gamma, I mean we have gamma like this, then automatically it is equal to this. We call this one recurrence gamma function. Okay. For example,
Yes, sir.
if you say you have say for example this one, if you say we have gamma of say 4, it therefore implies that this is like gamma of what? 3 plus 1. 3 plus 1 is enough for Hello, answer me now.
Sir, the network is not good. I can't hear you, sir.
Can you hear me
Hello,
now?
sir.
Can you hear me? Can you hear me?
Hello, sir.
Are you using your phone or are you using laptop?
Yeah, I'm using phone, sir.
Okay.
The network is bad. My God.
I think thank God I'm recording it anyway. Let me just be teaching you. If you get it fine, if you don't get it, I'll send a recorded one through any means.
Yes, the network. I'm getting it, but the network is bad, so it's breaking. I can't hear it completely, sir.
So what should I do?
Oh my God.
Okay, don't worry, I'm recording.
Okay, sir.
If you were using laptop, you would have enjoyed it. So now this is like gamma of 4. Are we there? It's just like saying gamma
Yes, sir.
of 3 plus 1, right?
Yes, sir.
And when you look at this formula, it says that whenever you have this, 1 is on this side. It therefore implies whatever value that is here, put it here and repeat it here. So this one now, it becomes what? We take this value 3 and then you repeat it like
Yes,
this,
sir.
right? And then this one
Yes,
now,
sir.
we're having gamma of 3. So when we have gamma of 3, it's just like saying that what? Now, this is just like we say 3 into, this will become gamma of what? 2 plus 1, right?
Yes, sir.
Now, if we say gamma of 2 plus 1, this is just like saying 3 into gamma of 2, 2 into 2, right?
Yes, sir.
And then if we proceed with this, we're going to see it's going to be 3 dot 2 dot 1. So it therefore implies that gamma of 4 is just equal to what? 3 factorial. Because if you see, we have gamma of 4 is like 3 times 2 times 1. And 3 times 2 times 1 is 3 factorial. Is that true?
Yes, sir.
Perfect. I wanted to know if you are there. So this is a special function. Now, anytime you see just this, anytime you see gamma of n, is just saying that it is gamma of, it is n plus 1 factorial. N minus 1 factorial, sorry. Right? Just like we say
Okay, sir.
gamma of 4, or let's say gamma of 5. Gamma of 5 will just be equal to what? 4 factorial.
Yes, sir.
Correct. We have seen it already. So that is what this thing is saying. And that is, we got it from here. Okay? Don't underlook this formula.
Yes, sir.
This formula will always, you will be using it. And this formula also will be using it. Then another thing is, anytime you get gamma of half, gamma of 1 over 2, or say gamma of 0.5, this is just equal to what? Root of pi. Right?
Yes, sir.
Then the last one is, this one is very interesting. Again, if you have gamma of n plus 1, this one is just equal to what? N factorial.
Factorial.
So for example, let me say, if I say, okay, um, gamma of 8, what is this? Find gamma of 8. This is how many factorial?
Hello, sir.
Gamma of 8, this one will give you what? What is the value?
Sir, I can't hear you, sir. The network is breaking. Gamma of 8.
Gamma of 8 is what?
So if it's gamma of 8, that one will be 6 factorial. But if it's gamma of 8 plus 1, that means it will be 8 factorial.
No. Come back here. Gamma of 8. If you see 8 here, you take 8 minus 1. That is the factorial. Gamma of 4.
It will be 3 factorial.
So gamma of 8.
You need to break.
Gamma of 8.
It will be 7 factorial.
Perfect. Then now how do we use this? Now if you have, say, gamma of 5 plus 1, this will be how many?
It will,
This will be how many factorial?
this will be 5 factorial.
It will be 5 factorial. You got it now. Which is the same like gamma. This one is like gamma of 6. Right?
Yes, sir.
So what we are doing is everything here is just the same. The only difference here is this. So let's move to the next one. Now this second part is beta function. What is beta? Beta has something to do with gamma. Okay? So I can
Yes,
actually
sir.
prove that this is the beta of m and n. Anytime we say beta of m and n, this is how you express it. For example, if I say beta of 5 and 3, they are always separated by comma. Find this expression. This is just equal to what? Gamma of what? Gamma of 5 times gamma of what? 3 all over gamma of what? 8. And we already know that gamma of 5 is how many factorial? 4 factorial.
It's 4 factorial. Yes, sir. 3
Times
factorial.
2 times 2 factorial
Over 3 factorial.
all over 7 factorial. Bye-bye.
Mm.
Whether you are going to well, now you know. Whether you are going to space. So that is how this is. Is that okay?
Yes, sir.
Perfect. Now
Okay.
this is how we prove this. Whenever you are given, for example, I can actually say use beta. I can give you an integration. Now, what the key point for you to look at is these points and these points. Okay, it must be from 0 to 1, and then are you with me?
Yes, sir.
It must be from 0 to 1, and then you must always find a way of identifying your m and your n. So if you look at this, so far as we have expressed this, then our m, so far as it is like this, our m is here, our n is this. So automatically, you can always solve it leading to this. So this expression can be obtained using this transformation. We're going to do that, don't worry. I just want you to look at something. Now, for example, I just taught you how to evaluate. I said find beta of 3 and 2. So beta of 3 and 2. This is a, if I ask you that, this is the formula you put. Are you with me?
Yes, sir.
So now, this is again, we'll move to the next step. So gamma of 3 is 2 factorial, gamma of 2 is 1 factorial, and gamma of 5 is 4 factorial. So by the time we do this 2 factorial, this one 2 factorial is 2, and 4 factorial is 24. So this automatically give you your answer, right?
Yes, sir.
Perfect. Now the next one is, I want us to see. You see now, this thing we just did is equal to this. In the sense that, now look at this. I said, compute this. I do not ask you to use anything. I just gave you your exam. Compute this. The first thing you identify is this integral is from 0 to 1. Is that okay?
Yes, sir.
The next thing is it a beta or a gamma function? Now, this one we're going to use a beta function. Then when we use beta function, it's related to gamma function. So in this case, you will now think of how can we make this, how can we take this to compare it to their general formula? The general formula of gamma is saying that if you take an integral of this to this, it must have this expression. If it has this expression, then it must be equal to this beta, right?
Yes, sir.
So if you look at this now, how can this become this? Now this is 2, but this is saying that it's m minus n. So what value of m can you put such that we're going to have 2? What value of m you put here such that it will give you 2?
That is 3.
3, correct. So if you put 3 here, it will be 3 minus 1, that is s squared. So we have gotten our m to be what? 3, right?
Yes, sir.
Then the next thing is, since this one is already this place, what value of n would you put here to get 1? What value of
That's
p?
2.
2. So now you have been able to get that your beta is expression of 3 and 2. 3 and 2. So by the time it's 3 and 2, we'll get 1/12. Is that okay?
Yes, sir.
Now the next one is, how do we evaluate this? How do you evaluate this? You keep, this is a recurrence. So for us to evaluate this is a what? Recurrence relation. The first thing is, we'll do what? We'll use a formula of recurrence, right?
Yes, sir.
This is 0.5. So you're going to -1, you keep -1, keep -1 till you arrive at the final answer. So for example, this is 0.5. Now you're going to do -1. You know why we're doing -1, right?
Yes, sir.
Because this is +1. So you're going to do, this is 0.5 -1, you get 4.5. Then you put 4.5 here. Then you come and take 4.5, you get 3.5, 3.5 here, you do for 3.5. So such that at the end of the day, you're going to have 4.5 times 3.5 times 2.5 times 1.5 times what? Now,
Half.
times half. So you realize that when we put this substitution here, our final answer will be what? 4.5, 3.5, 2.5, 1.5, and what?
Pi.
And when you do this, you get your final answer. Is that clear?
Yes, sir.
Perfect. We're moving the way I want. Now, the next thing is, evaluate this. Very straightforward. 24, right?
Yes, sir.
The next question is, show that this is equal to pi. Now, we are saying that this is equal to pi. How do we show that? In the exam, if I say show that this is equal to pi, then you're going to bring back this formula. What is the formula?
Integral
You're going to bring our
gamma
definition.
1/2.
We're going to bring our definition, which is n is equal to integral of what? 0 to what? Pi. I mean to
1.
infinity. My dear, where are you?
Mm. Infinity. Yes, sir. Sorry, sir.
Where are you? This is infinity. Then this will be, I said you can either use x or you can use t, right?
Yes, sir.
So let me say, okay, since there's t here, let me use t. This will be t. What will be the power here? n minus what? 1, right?
I -1. Yes.
Then e to the power minus what? T, eh?
Yes, sir.
dt, right? Now, in this
Yes,
case,
sir.
they have asked us find gamma of 1/2. So this will just be integral of 0 to infinity. Then we're going to have what? This is going to be, what value is here? This value will be half minus this, so it's going to be -1/2.
Mm-hmm.
Then we have e minus t, then dt.
DT.
That is why we got this. Have you seen that?
Yes, sir.
Now, if we are able to get this, then we'll do substitution. Everybody knows how to do substitution. You now say let t be equal to this. If t is equal to this, then dt, we're converting the t to x so that life will be easy. If t is equal to x squared, then the t will be equal to 2x dt, right? Then we substitute. So anywhere you see
Mm.
t, you put x squared, right?
Mm.
Anywhere you
Yes,
see
sir.
t, you put what?
S square.
X squared. So if you put x squared, this we're going to have this -1/2, and then you're going to put the t. The e here remain, minus t. Then you put the t. The t is what? 2x dx.
DS.
Now, anywhere you see t, you put x squared. Sorry, this one's supposed to be x squared. So this will be minus x squared, right?
Yes, sir.
So now, what is this? This becomes, by the time you simplify, you realize that this one becomes -1, which is just like 1/x. Then this one will become e to the power x squared minus x squared, right?
Yes, sir.
2x the x,
ds.
and that is this, right?
Yes, sir.
Now, what next? You bring out this outside. What happened? This x will chop out this x. This x will chop out this x, right? This x
Mm-hmm.
will cancel
Yes,
out
sir.
this x. So the only thing that remains will be two of these. So the next thing is we're going to find out this integral. And the good news is that this
Mm-hmm.
integral is a kind of integral that we can obtain anywhere in the book. So we say it is referred to as the Gaussian integral. So it's better you get it at the head, top of your head. Anytime you see this integral, right, it's
Yes, sir.
always root pi all over 2. Okay, no need to go and be solving. Anytime you see this integral, it's just root pi all over 2. Is we call it a Gaussian integral. There are a lot of them. If you study the physics, mathematical method in physics, you see a lot of integral and their values. We call them special integrals, right?
Yes, sir.
So if I ask you in the exam, you just say, okay, recall that this is a special integral, and this value is equal to root pi all over 2. Therefore, then you now remember these 2. So this 2 is equal to 2 times root pi all over 2. And then finally, you have been able to prove that, right? So you have been able to
Yes,
say
sir.
this is equal to this. Check up.
Okay. Yes, sir.
Thank you. Now, the next one is prove this recurrence. Prove this recurrence. The same thing I just did is the same thing you will do. So if I say prove this, you will still start by using the factorial of, say, n is equal to, remember, is from 0 to infinity.
Yes, sir.
Then it's supposed to be t n minus 1 e minus t
Minus t
dt,
dt.
right?
Yes, sir.
So what is here? Now this is saying that z plus what? 1 is already taking the place of n. So this now will be equal
Mm.
to integral of 0 to infinity t. Then this will be what? Z plus
Z
n
mm-hmm.
minus 1
Mm-hmm.
all over e minus t dt, right?
Yes, sir.
Perfect. So if you take this one very well, you realize that this will be 0 to infinity. This will be t to the power z, because this guy will be 0. E to the power minus t, what? dt, right?
Dt. Yes, sir.
That is what we have here, right? Now, the next thing
Yes,
is
sir.
you go by substitution. You say let u be equal to this. And then if u is equal to this, you are integrating by part. Then you now have to integrate. Then dv will be equal to e, will be equal to this by that. Dv will be equal to this whole thing, right?
Yes, sir.
Then you substitute. Immediately you do that substitution and then simplify, you're going to realize that the whole of this, you want me to do that because it's very simple. You just put this value here, okay? All this thing here will give you 0, and this part will give you z root that. Okay?
Yes, sir.
Perfect. Then the next one is, this one, I know this one is bomb to you, it's not difficult. Evaluate this using the recurrence relation. What will you do? If I ask you to do this, anytime I say you to do this, let me give you one simple method. 7 all over 2, always try to minus 1. Minus 1 is just like 2 divided by 2. So now you take the up. This minus this will be what?
Yes, sir.
5
5
over 2.
over.
So that is where we get 5 over 2. You see how it goes. Then from here again, you do minus 1. That is minus 2 all over 2. Continue doing that until you arrive at our final point, right? 5
Yes,
over
sir.
2, 3 all over 2, 1 all over 2 by this. And we know that this value is what? Pi.
That is pi.
Correct. So by the time you do this times this is 15, and then pi all over 8. This like this. So this one is very simple, right?
Yes, sir.
Then the next one, let me see if I can delete this thing. Um, are you understanding what I'm doing here?
Yes, sir.
You have taken this class before, so I can see it. Are you enjoying it
Yes, sir. Seriously.
with your phone?
Yes, sir.
Oh, okay. What type of phone are you using?
I'm using Android, sir.
Oh, okay.
A70.
You're a big woman. Are you not a big woman in Unimade?
But I'm a small girl.
You're the ones now controlling Unimade.
Ah, sir, I'm a small girl.
Girl, how many children? You have like two children. You say you're a girl. You're a woman now. Yeah, I just want your brain to be relaxed. You've been in the lab throughout today, right?
Yes, sir.
What you did you take any exam today?
No, sir, I'm trying to do my practical, complete my practical manuals.
Which one? What level you are taking practical manuals again? Are you undergrad? I mean,
Uh,
100 level.
yes, the practical is, no, 300, electronics.
Okay, who is taking that course?
Is Dr. Adebayo, but he hand over it to Mr. Soladoye.
Okay, and Salado is handling it very well.
Yes, sir.
Everybody, yes sir. No wahala, sha. Okay, okay. Let's come back.
All right, sir.
So evaluate this now. In the exam, I give you this one. You don't say, ah, thank you, Jesus. I like this man. 1 plus 1, right?
Yes, sir.
You say yes, sir. It's very easy, right? Now, if I give you this, the first thing I'll look for is your formula. So you must give me this formula, and then you express it, and you say, thank you, Jesus, for this question, right?
Yes, sir.
Then you move forward. So now the next question is now show that this is equal to this. Now, for you to show that this is equal to this, is very simple. You just need to bring back the definition. Remember, the first thing is for the difference between the beta and the gamma. The gamma has to do with from 0 to infinity. The beta is from 0 to 1. You get that?
Yes, sir. Yes.
So now show that this is equal to this. So the first thing is you have to do what? You have to bring it out in form of this, right? This is a
Yes,
general
sir.
this is a general definition. Now when you change, you realize now how to do that is very simple. Okay,
Yes, sir.
how to do it? You will now let u to be equal to 1
Minus T.
minus t. Then if you let u to be equal to that, then you substitute one. Then what will you do? You say you let u to be equal to 1 minus t, right?
Yes, sir.
Then you substitute here. Is there anything that you don't
So this
understand
one
here?
would be.
Then you do
I
the
understand. So
you do du dt. Then
okay.
from here you can make t the subject. If this u is equal to 1 plus t,
1 minus T.
then what will be t? U, what will be t?
T will be -1.
1 minus u. T will be 1 minus u.
Okay. Yes, sir. Sorry.
T will be what?
Yes, 1 minus U.
Then what will be
Mm.
we're looking for dt. What will be dt? What will be t? Minus the u, right?
Yes, sir.
Now put all these things here. So you see, if this is t, then it will be 1 minus t, 1 minus u. This one remain. That is where we get it. 1 minus this. Then this is
Yes, sir.
u. That is it. This thing
Mm.
remain. And then the u will be equal to, the t will be equal to that, right?
The T is equals to the. Yes, sir.
The t equal to du.
Yes, sir. The T is equals to the U. But sir, the I think it. Okay, sir.
No, not okay.
I have a question, sir.
Go ahead.
Sir, according to the proof in here, the T is equals to minus the U.
Mm-hmm.
But coming to the equation, it's only the U that we are having there. Integral is 0 to 1. open bracket 1 minus u raised to power n minus 1 u raised to power n minus 1 du. So I'm talking about the u that is there.
Mm-hmm.
So yes, sir, what I'm saying is that the t is equals to minus the u, but here we are seeing only the u.
Wait, there's something I want to look at. No, do du by the TLSC. Let's differentiate line by line. This will be du by the t,
Okay.
and this will give you minus. Doing again, let's see. Um, this is the t will give you minus the u. Um, are you there with me?
Yes, sir.
Let's see. One minus t. And somebody is there with you.
No, sir.
Yeah. Um. Okay. It's correct. There's no problem. Let me show you what happened there. Uh, now, okay. What happened is now what we are trying to do is if you put minus is correct, right? Eh? Hello, are you with me?
Yes, sir.
Yeah, but
Yes, sir.
now what our problem is, we want to show that bm is equal to nb. I mean bmn is equal to nb. B into m and n is equal to b into n and m, right? Now,
Yes, sir.
if you if you if you convert, take back your t and make sure that every t appears back in terms of t, they are going to see that even with the minus, just do it. You realize that it will be equal to b of n and m. Try it and let me know.
Okay, sir.
Yeah, just try it and let me know, okay? Follow
Yes, sir.
this integral again and make sure that you realize, because our target is this is all in terms of t. But if you look at this is in terms of u, right?
Yes, sir.
So you cannot say this is equal to this until this one you now change all these things these things back in terms of t, and then you're going to get nm,
Yes.
which of course is saying that b of mn is equal to b of nm. Now there's another one again. Now, for example, now like this one, prove that B of Mn is equal to this. This one is straightforward, right?
Yes, sir.
Okay, so all you just need to do is going to just let your t be equal to what? This is what I've given. So let your t be equal to sine square theta, and then your dt will be equal to what? Dt will be equal to 2 sine theta cos theta. Now,
Yes. Yes.
anywhere you see t, you put this. Anywhere you see dt, you put it, and you're going to have expression like this. Okay? And
Yes,
automatically,
sir.
you have been able to show that b of this is equal to that. Right?
Yes, sir.
Very straightforward. Then now we can evaluate this one too. This one too is very straight to evaluate, right? Root pi, all over 1. That is this evaluation, right?
Yes, sir.
Then show that this, again, this is another good one. Show that this is equal to this. For you to show that, now you can see that we are now converting from 0 to 1. Now, this is still beta. This is now from 0, I mean, from 0 to infinity, just to be like gamma, right?
Yes, sir.
So for us to show that this is equal to this, then we have to take this conversion. We have to take this. So by the time you take this, let this equal to this, then you carry out all the differentiation and everything. You are going to arrive at this. If you, it's a very straightforward something. You want me to let this is equal to this, right? Then the t by dx will be equal to what? Hello, are you with me?
I'm with you, sir. I want to do it, sir.
No, don't worry. Before the end of the class, we'll come back and do it. If you are not able to do it,
All right, sir.
I will just do it on the black of white paper and then snap and screenshot and send to you, right?
Okay, sir.
Yeah, it's just a straightforward something. So this is a very strong evaluation problem, and this is what is referred to as the hypergeometric function. The key point here is you can see that this f has 2 and 1 here, and these are some values. We're saying that evaluate this value. I say evaluate this value. Automatically, this is the expression. We're going to see why is this expression going to be like this, and then therefore it's going to give you the whole of this is just ln 2. How can the
Okay.
whole of this change to ln 2? That is the magic in mathematical method in physics. Okay, you laugh.
Yes, sir.
So that is why I say we're going now to what is referred to as hypergeometric function. Have you ever heard of hypergeometric function?
Yes, sir.
You've heard about it.
Network.
Joseph,
Oh.
Joseph,
Sir, I'm listening. Sir, I'm with you, sir. It's the network. Oh, the network is breaking, sir.
have you heard about hypergeometric function?
Yes, sir.
Okay, it is actually a power series solution to what? Hypergeometric differential equations. Can you hear me?
Yes, sir.
Now, there are important things that you need to note about this formula. Remember, I put there it was 1, 1, 2, x. Come back. 1, 1,
Sir,
2,
it's no
minus.
more on the screen, sir.
Eh?
The equation has left the screen.
How manage? Are you seeing?
No, sir. Maybe it's network.
Ah, this is where I want it to be very, very. This is where the class is about to start. Are you there? Are you seeing?
No, sir.
What happened? Are you not seeing? It's showing that it's showing.
It's not showing, though. It's only saying that you are presenting.
Are you with me?
Yes, I'm with you, sir.
Okay, let me see again. Are you seeing it now?
No, sir. Maybe we'll continue, sir. When you send the recording, I will able to go through it.
No, this one,
So that
this thing I want to tell you now is something very important, and I needed you to see it. Oh,
okay, sir.
are you sure you're not seeing my
It's
screen?
the
Because
network.
no,
Siri, I'm not seeing it, sir. It's the network. Okay, yes, it's back now.
what is back?
Yes, I can see it now. It's showing on the screen now.
What is showing? Read it.
It's plain though.
It's plain. Okay. Are you seeing it now? Are you seeing my
Sir?
screen? Are you seeing my screen now?
Yes, I can see the screen, but it's plain.
Check now. Are you seeing it?
Yes, sir.
Is it plain?
I, no, sir.
Thank God. Let me be very fast before the thing reach. Um, are you seeing it now?
Yes, sir.
Now remember, the first thing you need to do is these are key point. These 2 and 1, okay? It's talking about
Yes, sir.
it's a kind of hypergeometric function, and I say it is a power series solution for what? Hypergeometric differential equation. The most important thing that you need to know is this A, B, C, and Z, right?
Yes, sir.
If I ask you to evaluate, like for example, the one I asked you, A, B, C, and Z, this formula is very simple. You just say the summation from zero. That means this one they say n start from zero to infinity, right? You say A, B,
Yes, sir.
C, and n. A, B, C, then Z, then factorial, and the n. It's very simple. This
Mm-hmm.
formula is not difficult for you to memorize, okay? But what I
Yes,
need
sir.
you to understand is what is referred to as the Pochhammer symbol. The Pochhammer symbol, these are the symbols. You have one. How many Pochhammer symbols here? One. Another Pochhammer symbol. We have two.
Two,
We have another one
two,
here. Three. We have
three.
three Pochhammer symbols. Now, what is a Pochhammer symbol? Pochhammer is talking about how you can change it into factorial. Okay?
Okay. Yes, sir.
Yeah. So, special case is that, for example, if I ask you to express this, okay? In the other case, you remember this is -1. So if this one was -1, then you're going to see that this whole guy here will be what? If this guy is +1, you will see that this guy will be ln 2, right?
Yes, sir.
And we're going to prove that. You see, what I said is, okay, if this guy is negative, this guy will be that. And you say again is ln 2. So we're going to see why is it ln 2. Okay?
Yes, sir.
Okay. Now the question now is show that this is equal to this.
Mm.
Show that this hypergeometric function is equal to just ln of 1 plus x all over x. The first thing we're going to do is we're going to define, based from our definition, what is a hypergeometric function. Hypergeometric function generally is defined as this, right?
Yes, sir.
Correct. I don't want to dirty this thing. Let me just be going gradually. Now, the first thing we're going to look is, now, what are the values for A, B, and C? So based for this is what we say we should show. So based on that, our A is equal to 1, our B is equal to 1, our C is equal to 2. Right? Right?
Yes, sir.
What is our Z?
One, sir.
Z is equal to minus X.
Ah, no. Can you show?
Are you seeing what I'm doing?
No, sir.
Are you not seeing my screen?
I can't see it, sir. Ah, bye. I can see it now, sir.
You can see it.
Yes, sir.
Okay, if you can see, what is our A?
Our hair is 1. Our B is 1, our C is 2,
What is
while our Z is minus S.
okay? Okay. So in that case now you can do go ahead and just say okay, this is equal to, you put everything here, right?
Yes, sir.
Our A is 1, correct? Our B is 1, correct? Our C is 2, correct? Right? So how many Pochhammer function do we have here? We have the first Pochhammer
We-
function is 1 of what? N, right?
Yes, sir.
The second Pochhammer function is 2 of what? N, right?
Yes, sir.
So how do we expand this? So to expand this, we move to the next step. So in this case now, this is the Pochhammer symbols. This is how it is being defined, right?
Yes, sir.
Now in this case, if you look at this one, our first case here, A is equal to 1. Like this one, now A is 1, right? So A is equal to 1.
Mm,
So this is how we put it. So if A is equal to 1, anywhere you see A, you put 1. So 1, 1 plus
mm.
1, right? So you see this is 1,
Yes, sir.
2, 3. So if you have 1 times 2 times 3 up to, that is what? N factorial. So for the Pochhammer series, I mean for the Pochhammer symbol, right? 1
Yes, sir.
is just equal to N factorial, right? The next thing is for
Yes, sir.
the one in case of where C is equal to 2, therefore A is equal to 2, right? It therefore implies that you have 2, 3, 4, and go on and on. 2, 3, 4. So therefore, this is going to be what? N plus 1 factorial. N plus 1 factorial, right?
Factorial. Yes, sir.
N plus 1 factorial. So N plus 1 factorial is equal to what? You start from 2, 3, 4, up to N plus 1, right?
N. N. Yes, sir.
Uh-huh. So that is how we represent all these functions. Any problem? I'm not happy because your network sometimes
No,
misbehaves.
no, sir. There's no problem, sir.
Okay. So if I ask you now to give me this value, 4 of n, what is this?
That is 1, 3 factorial, 3n
This will be what? This will start from
times,
what? This will be
sir.
four. This will be what? 4.
This will be 4 open brackets,
No,
4
4
plus
times
1.
5 times 6, 7,
Yes, sir.
8. These are all times. So what factorial is this? Sorry. This will be equal to what? N plus what factorial?
Yes, sir.
N plus what?
This will be what will be 9, 9, 9.
Yeah, you're not with me. Oh. This will be how many factorial? This will be what?
This will be 7 factorial. N plus 1, that one will be now be 8 plus 1, it will be 7
See,
factorial.
when it started from 2, it will have 2, 3, 4, 5, 6, 7, 8, 9, 10 go up. Now we are starting from, okay, let's say if we start from 3, it will be 3, 4, 5, 6. So this will be what? When it is 2, this will be n plus 1. Then if it is 4, it will be n plus what? Anytime you must make it to be plus 1. So what plus 1 will give you 4? Wetin plus 1 will give
Okay.
you 4?
That is 3, sir.
Eh?
That is 3.
So this will be equal to this. Wait. Something is wrong. Something is not correct somewhere. Um, wait. Now, if we put it like this, hold on. I want us to do something. Me and you.
Okay, sir.
Why do we put n plus 1? Such that when you put 1 here, this series starts from 1. 1, 2, 3, 4, 5, right?
Yes, sir.
For example, if you put this one here, you get this. If you put this one, you get 2, 3, 4. So it means that this is n plus 2. N plus 3 will be 3 factorial, it will be this. Then this is equal to n plus 2.
Mm.
Why? Because the first value you put here, if you put n is equal to 1, you get 1 plus 2, which is equal to what? 3. The next one, if you
Mm.
put
Mm.
2, you get 2 plus 2, which is what?
4.
4. The next one is if you put 3, you get 3 plus what? 2, which is
2.
what? 5.
5.
So this one is equal to n plus 2 factorial. So this one will be equal to n plus 3 factorial. Why? Because n start from 1, 1 plus 1, 1 plus 3,
Mm-hmm. Mm-hmm.
it will be 4. Eh?
Yes, sir.
2,
Yes, sir.
2 plus 3, it will be 5, right?
Yes, sir.
And then 3 plus 3, it will be
Be
what?
6.
6. So
6, sir.
so you can see that you are looking for the way you get 4, 5, 6, 7, 8. So this will give you this factorial. So if I ask you in the exam, give me the Pochhammer symbol for 13n.
Mm. Then I understand. So it will now be n plus 12.
Perfect. Your head is working very well. I hope you just ate eba now. Did you just eat
Okay.
eba? Your head
Okay.
was from somewhere. It just came back. Eh? You were scared?
Okay. Oh, no, network.
Ooh. Joseph,
Sir,
are you with me?
I'm with you. It's not okay. It has come back.
It has come back. It's your phone. I say, were you eating eba?
Yes. So I don't like eating about. When I eat about, my stomach will be paining me.
Because you just came back. I took time to explain this. It's like you were not understanding. Now you just understood.
No, it was because that thing was just for 20. It will go, it will come back. So I can't really concentrate. But now, when it really stays, so I really understand.
Okay, let's move. So now the next thing is, therefore, our series now becomes what? We have seen that our Pochhammer symbol for this is n factorial, right? So we have how many of
Yes, sir.
these? From here we have we have the Pochhammer symbol for here. This is n factorial, and then this one is what? N plus 1 factorial. So that's why we get n factorial, n plus 1 factorial. So this part is perfect, right?
Okay.
And then we only
Yes, sir.
one value still remain, so that is it. Therefore, if we simplify this, automatically this will cancel out with this, and then we're going to arrive at this, right?
Yes, sir.
Uh-huh. And then, so what is this now? This now can be simplified to take this form, okay? The whole of this is
Yes, sir.
for 1, because this the Pochhammer here was 1, the Pochhammer here, I mean the Pochhammer here was 1. So this one now
Mm.
convert in simple form. This one now, since is this is 1, and then this one stands for n plus 1, right?
Yes,
So
sir.
this one is for the C part, this is for the 2, right? So this guy
Yes, sir.
has been simplified to take this form, okay?
Yes, sir.
So there is no longer power series.
Mm.
So we can move now to the next step, right? Now,
Yes, sir.
for us to move to the next step, we have to bring out a definition that you know best. What is the definition? The standard a series expansion for ln 1 plus z is given by this. This is a general expansion, Taylor expansion, right? All of us know
Yes,
about
sir.
it, where z can never be less than 0. So for this expansion, this value here, it just symbolizes alternation. This value here, it's just telling us that Taylor series starts from -1, negative to positive, negative, positive. That is the meaning of this sign, right?
Yes,
Negative,
sir.
positive, negative, positive. So that's the meaning of these. That's the meaning of these points.
Okay.
The only thing here is this is the point that is changing. Now, if I tell then if we differentiate both sides, we differentiate this side and this side. Why do we differentiate both sides? I want to make a comparison such that I'm going to say this hypergeometric function is equal to this lane of that, right? So anytime you see hypergeometric
Yes, sir.
function, you can equally equate it with this. But for it to be equal to this, A must be 1, B must be 1, C must be 2. If any of these things change, for example, I
Okay.
put 4 here, I put 2, 2 here, it cannot work. Then you have to follow through all these things that I'm doing, right? I can just ask you in your exam,
Yes,
give
sir.
me the expression for this function. The first thing is you see 2 here, you see 1, right? Then you see if I put 4
Yes, sir.
or I put 3, 2, or 2, 3, 3, 1, or 3, 3, 7 minus x, then what you do is you're going to give me the Pochhammer and then you're going to end here. You're going to end somewhere here.
Okay.
Okay? You end somewhere
Okay.
here. But if I
Yes,
say
sir.
proof, if I say just give me the expression, if I say proof, that's when we're going to do what I'm doing now. If I say give me
Okay, sir.
a Pochhammer for I give you any value, you are going to stop somewhere here, right?
Yes, sir.
Okay. Now, so you can see the end of the solution is saying that if you differentiate both sides, okay, and then make some comparison,
Yes, sir.
comparing with our series, we're going to realize that this whole thing is going to be equal to this. But the question you may ask me is, sir, how do we differentiate? How do we compare? How does that change? That's the question I want to ask, right?
Mm.
Eh?
Yes, sir.
Okay, let's see how it goes. Now, as I said, let's recall from terror series. We know that from terror series, lane of this is equal to just what I've mentioned, right?
Yes, sir.
So, for example, from this terror series, I say give me the first 5 terms. So if I say give me the first 5 terms, the first term will be what? When n, you see n is equal to 1. So you start with n is equal to 1. When n is equal to 1, then this will be minus to the power 2. Minus to the power 2 is plus, right?
Yes, sir.
So you see that there is a plus sign here. Then you see this is 1. So z to the power 1 is z all over 1. So you see that we only have
One.
z. So this thing is 1. Now the next one is when n is equal to 2. When n is equal to 2, what happened? This will be equal to 2 plus 1, 3. Minus 1 to the power 3 is
Mm-hmm.
negative. That's why we have negative here, right?
Yes, sir.
Then when n is equal to 2, then this one will be now z to the power 2 divided by 2. So you see
Mm.
how this one came about, right?
Yes, sir.
Then we continue. You will have the third one. This the now when n is equal to 3, 3 plus 1 is 4. So this to the power even will give you plus. So you remember this is 3, this is 4, this is 5, this is 6. So you see it alternate plus, negative, plus, negative, plus, negative. This is taking care of that. And then this expansion is correct, right? It's okay. You don't have problem, right? Hello?
Sir, it's breaking. The network is breaking. Hello, sir. I can hear you now. The network is breaking before.
So if I say give me the first 10 or give me the first 3
Okay.
terms for this expansion, you'll be able to give me, right?
Oh my God. Hello, sir.
Are you there? Are you there?
Hello, sir.
Are you with me?
Yes, sir.
Can you hear me?
Yes, sir.
Okay. Mind you, what I'm trying to do, are you with me?
Yes, sir.
What I'm trying to do is to just to show you that this side is equal to this. That's all. Eh?
Yes, I'm with you, sir.
Otherwise, if I ask you this question in the exam, you can move from here and then from here you just write this thing and give me this answer. I will mark you correct. I'll give you all your marks. But now, if I want
Hello,
to
sir.
say, Ash, ah, are you with me?
Yes, I'm with you, sir. Sorry, sir.
I'm having headache teaching when I'm repeating something over. Are we there?
Sorry, sir. Yes, sir.
Now, this series start from, if you look at this series, this natural logarithmic or logarithm function. If you look at it, n stands for 1. But if you look at the hypergeometric function, n starts from 0. If you look at it, hypergeometric function, right?
Mm.
This is it. N starts
Yes,
from
sir.
0, right? Because for this one, since
Yes,
n
sir.
starts from 0, and then for our log, n stands for 1, we have to find a way of making sure that this index and this index align. Either it starts from a particular value, say 1, or it starts from some particular value, say 0, or it starts from some
Mm.
particular value. We can call that value, say k. Are you with me?
Yes, sir.
Okay. So that's why we're saying that this series starts from 1, but for the hypergeometric function, the series starts from n equal to 0. Therefore, we have to align the indices. So if we want to align the indices, we have to differentiate both sides. Is that clear?
Yes, sir.
So now, this is what we're saying.
Mm.
We have the hypergeometric series start from 0. We have the logarithmic
Mm.
series start from 1, right?
Start from 1. Yes, sir. Yes, sir.
So because of that, we must align it. So for us to align it, we have to differentiate. So when we differentiate, then we are going to align it, right?
Yes, sir.
So let's see how we differentiate. So let's now differentiate this one, because we want, when you differentiate, when you're differentiating, you're going minus backwards. You are minus 1.
Minus 1.
So we're going to
Yes, sir.
differentiate by the one that has n start from 1, so that it goes back to n to 0. So now we're going to differentiate by what? The logarithmic function term by term. So to transform it into the resemble hypergeometric series, we differentiate both sides. So when we differentiate this side and differentiate this side, what do we get? Are you with me?
Mm. Yes, sir.
Remember that the differential of this is equal to this. Period. If you
Yes, sir.
differentiate this, is equal to this, right?
Yes, sir.
Perfect. So we have differentiated the first side. Well, so you're going to differentiate this side and this side. So 10 by 10, we have already
Okay.
differentiated this side. When we differentiate this side, we have what? 1 all over 1 plus
1
z.
over 1 plus 1
The
plus
next,
z.
now we have to differentiate this side now, right?
Okay, sir.
So we have already differentiated this side, and we have gotten the left. Is that the left hand side? Gotten that. Now the right hand side. Let's differentiate the right hand side. So if we differentiate the right hand side, we're differentiate with respect to z. So the whole of this side will be the same. The only thing that will be differentiable is this section. So this will become n
Yes,
raised to
z
the
raised to
power
power
minus
n
1.
minus 1. Yes, sir.
Perfect. So this is correct, right?
Yes, sir.
Perfect. So since n in the numerator cancels with the denominator, this one cancel with this, then we arrive at this. Is there any problem there? Just say, are
Okay.
you with me?
Sir, I'm with you, sir.
You cannot understand why we move from this step to this step, right?
Yes, sir. Yes, sir. I understand.
Now, using the known Taylor series, we have already known. You know how this one came from, right? Differential of the left hand side, and then this is differential of the right hand side. You know how we arrive at this?
Yes.
So
Yes, sir.
now let me go back so that I really make you understand something. Because we have reduced, this one has become n, and everything becomes like that. See, we arrive at this, right?
Hello, sir.
Are you with me?
Yes, sir. Yes, I'm with you, sir.
Okay. So we're going to use, this is using the known Taylor series. This, we know where this one came from. We know where this one came from, right?
Yes.
So therefore we have obtained this. We have shown that this is equal to this. If you are following me, yes. If you are not following me, you say yes.
I'm, I'm with you, sir.
Okay. Now the next thing is we have to, now since we already arrived,
Hello, sir.
yeah,
Oh. Hello, sir.
since we now arrived, this guy,
Hello,
this,
sir.
hey,
Okay.
are you with me?
Yes, yes, I can hear you now, sir.
I'm getting headache. Oh. Now the next thing is we need to integrate. So
Sorry,
if
sir.
if we integrate this thing here, let's say for example, this is, we're going to integrate. Are you with me?
Yes, I'm with you, sir.
D lane 1 plus z to be equal to, we're going to the integral of all these things, summation minus 1 to the power n,
Mm, mm,
z to the power
Z.
n,
Mm, mm.
right? Then the z, right? This one,
Yes, sir.
all this one n starts from 0 to infinity. So if you differentiate, if you integrate this guy will only remain, the left hand side will just remain ln of what? 1 plus z
Mm.
to be equal to the whole of this integral. So let's see how this integral. So to carry out this integral is very simple. To integrate, we add power, right? We add 1, then we divide it by
Yes, sir.
2.
Yes.
So you can see that
By the power.
so this is an integral, right? So the whole of this will be equal to, are you with me?
Yes, I'm with you, sir.
Minus 1 n,
N
then this will be
over N plus 1.
z plus 1
Mm.
all over what?
N plus 1.
Perfect. Then that is all. That is the integral, right?
Yes, sir.
Mm-hmm. So this exactly now, you remember this is the logarithmic. It was n to the, it was n1, but now we have reduced it to be n start from 0. So you realize that, and then
Mm.
the hypergeometric own also start from 0. So we have aligned the index, right?
Yes, sir.
If we have aligned the index, therefore we remember, you know where this value came from.
Mm. Yes, sir.
Now look at this. The whole of, what is this? The whole of this section, compare it with this. Compare this with this
Mm.
section. What are you going to get? See, this is, you have, remember, you are looking, compare this. For you to compare this is, compare this, right?
Yes, sir.
What are we looking for? Remember? Okay, this is it. This is what we are looking for. I said compare, so that, this one was already like, how do I put it? Um, Now I want it to look like 1 all over n plus 1. What do you do to make this one to be 1? This one is what this one is. I was confused. Are you with me?
I'm with you, sir.
Now this, I want this thing to be equal to summation. I want it to be comparable to this. When we say compare to this, that means you take this side, equate it to this side.
Okay.
So this will be n is equal to 0. So all of them already, n is equal to 0. n is equal to infinity. Then, yeah, then we have minus 1 to the power n, which I can cancel. Is just this one is just talking about it's just talking about sign, that the sign changes, right?
Okay. Yes, sir.
Uh-huh. Then this one is 1 all over n plus 1. The same thing with this one, n all over n plus 1, right? Now,
Yes.
this one now is z, but here we have what?
Zn+1.
N plus 1. How can we make now this one? Okay, this one now is equal to z n dot
Mm.
z1. Do you know that?
Yes, sir.
So now if you divide this, if you divide you divide now this whole thing now, because you must see it. If you don't see it, you will not understand. Should I write here?
Yes, sir.
Now this whole thing becomes, this is now n 0 infinity. As I said, this one is just a sign, so we can ignore it. Okay, so we just
Okay.
have
Yes, sir.
1 all over n plus 1. We have zn dot what?
Dot Z
Dot z.
n+1.
No, dot z now.
N+1.
Dot z
Okay.
now. Look at this now.
Okay.
This is equal to this now.
Okay. Okay. Okay, sir.
So this is what we have. So this is equal to what? Ln of what?
Mm.
This is equal to ln of 1 plus z now.
1+Z.
Yeah, from here straight. You know that this is equal to ln of 1 plus z,
Okay. Mm.
right? Now, the
Yes,
next thing
sir.
is we divide through by this. If you divide this, you divide it. So you have z here. So you have divided this throughout by z, right? So this one cancel.
Yes,
Then
sir.
realize that this whole thing here is
Mm.
equal to ln 1 plus z divided by z.
Mm.
So that is why we say, okay, this thing has changed. So this whole thing here is equal to ln of 1 plus z. That is why all this thing now. Have you seen it?
Yes, sir.
So we are saying that this this hypergeometric function is equal to ln 1 plus z all over z. Period.
Z.
So you can prove it, right?
Mm. Yes, sir.
I know you can prove it. I already know your strengths. I used to look at you like someone who doesn't really think. But I know that this thing I just did now is 1 plus 1. I think it's not difficult, right? You know how everything changed, right?
Yes, sir.
The only thing here is you must be able to know that this is just a sign and how to play with the sign. That's all. So I can ask you to prove that. So, okay. So should I be deleting it or should I be leaving it?
Leave it, sir.
You should be telling me now so that I should not be. So now
Okay.
we have seen that the hyper geometric series for this whole thing 1, 1, 2, and z is equal to this. But remember,
Yes.
the question was 1, 1, 2, and minus 1 or minus x. So let's see. So now, remember, it was 1, 1, 2 minus x. The next thing, please, Joseph, are you there?
Yes, I'm with you, sir.
Look at this. If you I ask you, you mistakenly remove this, you did not put this, you are wrong.
Okay.
Be very careful with it, right?
Yes, sir.
Uh-huh. So now, finally, our z is equal to negative x. So we have to substitute it. So you can see now that when you substitute it, you see that this whole thing is equal to ln 1 plus x all over
Yes,
z,
but this
as
over is yes,
as
sir.
we were required to show. So I hope hypergeometric function is 1 plus 1 to you, right?
Yes, sir.
Okay. Now, let's go back to.
But I have a question, sir.
Go ahead.
So the final answer where we need to substitute x is equals to, we said anywhere we see z is equals to minus x. Now looking at it, which is ln plus 1 on minus z over z.
Mm-hmm.
When we get here, it should be, when we get ln plus 1 plus z what's it called s, the answer is minus s, sir. The minus this s is no more there.
Yeah, this is an error here. No, 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 no.
This place, that ln 1 minus bracket minus x over minus s is correct, but the
Mm-hmm.
final answer here, how the x, because minus times minus will give us plus, so how this minus of this s, this that is where I don't understand, sir.
Yeah, you have a point there. I did not. This is what they asked us to show, and we have seen that this is equal to this. And anyway, you see x, you put minus x. Mm, okay, you know what?
Okay, sir.
There's an error here. It's supposed to be minus here.
Okay.
It's supposed to be minus here. You understand?
Yes, sir. So that minus times this minus will give us plus.
Yeah, this one, this
Mm-hmm.
is supposed to be minus there, correct?
Yes, yes, sir.
So sorry about that. I think I will take care about that.
um all right, sir.
Any other question?
No, sir.
So in the case, at the end of the day, this minus was supposed to remain here.
No, there's no need of minus, because if minus is there times this minus will give us minus already. Will give us plus.
I don't understand what you're saying. No, it's supposed to
They
be like.
said
Yeah, it's okay like this because the general formula
yeah.
has nothing to do with minus.
Okay, sir.
Yeah, it is one that has minus. But come, something is not correct.
Okay, sir.
Okay, okay, okay. We solve it and we realize that we have one minus correct. Okay, okay, yeah. What happened here?
1 plus z over z.
And we now substitute now.
We substitute, yes, sir.
Why this
So we substitute.
no, this sign was supposed to be plus here. See now.
Sir, please, sir, take it back.
Wait, look at this. Anywhere we see z, we put minus x.
Okay, so it should be 1 minus x over minus x. Yes, sir, this one is correct, because sir, 1 minus is having minus there, and when we substitute x z himself, that x is having minus. Is correct, sir.
Are you anywhere you see z, you put minus, right?
Minus, yes, sir. The x will carry minus. So, but this one is plus, so that is where the challenge is. So it should be 1 minus x over minus x, not minus minus x.
So this one's supposed to be like this.
Yes, is you be lean. Yes. So this is what's supposed to be there. Yes, sir. So this the final answer here should be -2 minus z.
Correct.
Yes, sir.
What about that? Yeah. I'm going to look at it again. I'll show you. We'll look at it. Okay. Maybe something happened
Yeah.
there. Yeah.
Okay, sir.
I'll look at it because everything is correct up to this point. So if we are substituting x z is equal to this, it's supposed to be like that. Okay.
Yes, sir.
Okay. Now everything here will just be like revision. All these things. Okay. This is what I want you to quickly look. For example, if I ask you to evaluate this integral, the first thing you look at is the integral is from what to what, so that you know which one are we using. It's from 0 to infinity, right?
Yes, sir.
So therefore,
That's for
the next thing is you look at this power, and this power. This one is perfect, so this is gamma. So this one now is gamma. So the next thing is you are going to look for your n, because the formula is saying from 0 to infinity. Then if we are using x, it's going to be x n minus 1. Then it will be e minus x dx, right?
yes, sir.
So if we compare now, what value must we put here? What value must we put here to get 3? Correct, is it?
That's
What value can we put here? So it's just like say n minus 1 is equal to 3. That's
yes,
what.
equals to 3.
So
That's yes.
n is equal to what?
4.
Correct. So in that case, we are just looking for what? 4 factorial, which is equal. I mean, we are just looking for 4 gamma, which is 3 factorial. And 3 factorial is equal to what? 6. Right?
Yes, sir.
So this one is very straightforward. This one is just, that's it. Answer is 6. Okay. Now everything here is straightforward. So I was just trying to do a revision with you. So what will happen is I will stop the class for today. Then when we meet again next class, we'll be almost running up. I think you understood a lot of things today, right?
Yes, sir.
I would have been teaching people since, just that I lost my co-wife, so that's why I did not take it people. So we buried her
Mm.
on Saturday. So I'm a little bit free. Hey, sorry, I'm recording.
Okay.
Shift